Okay, so this will be 6-1, video number 2. And in this one, we're going to graph some of these exponential functions. I'm going to try to do this in pen just to make sure you can see it well. So it's asking me a couple of things. Tell whether each function represents exponential growth or decay, then graph the function. So step 1, identify the value of the base. So the base is always the number that has the exponent, which is a variable. So my base is 2. And if b equals 2, which is greater than 1, then I have growth. Now what I want you to do, as soon as you know you have growth, I want you to picture this graph in your head, up and to the right. So then when you get down to doing your graphing, if it doesn't look like that, you know or roughly like that, then you know you messed up somewhere along the way on your coordinate points. And then just like we've always done in Algebra 1 and Algebra 2, we're making a table of values. So I've given you the x values to use. They're the same x values we used when we graphed quadratics. And then you're finding the y. So our y is equal to 2 to the x. So what is y equal to when x is negative 2? Well, I'm going to have 2 to the negative 2. And when I'm doing these, I kind of fill in all this, and then I go back and simplify this. So this is x is negative 1. So 2 to the x is going to be 2 to the negative 1. X is 0. 2 to the x is going to be 2 to the 0. X is 1. 2 to the x is going to be 2 to the 1 power. So every time I'm replacing this x with these x values. And so this is going to be 2 squared. Okay, now let's look at these. This is like what we did in our introduction unit. We have a negative exponent. So that's going to be the same as 1 over 2 to the second power. 2 to the second power is 4. So this is going to be 1/4. Negative exponent, this is the same as 1 over 2 to the 1. Remember, send it downstairs, make it positive, make it happy. So this is going to be the same as 1/2. Anything to the 0 power is 1. 2 to the first power is just 2. 2 to the second power is 4. So these are our coordinate points. When x is 2, y is 1/4. When x is 1, y is 1/2. When x is 0, y is 1, and so on. I'm going to write these as coordinate points down here. I think it makes it a little easier when I start to graph. So my first coordinate point is going to be negative 2, 1/4. And then negative 1, 1/2. And then 0, 1. And then 1, 2. And 2, 4. Okay, so we're going to plot these points. So I'm going to go over negative 2 up just a tiny bit. This graph is kind of small. It's going to be hard to graph 1/4. Do your best. Over negative 1 up 1/2. Over 0, so I'm not going right or left at all, up 1. Over 1 up 2. Over 2 up 1, 2, 3, 4. Okay, so you can already see this is looking exponential growth-ish, right? Our graph is going to have this general shape, which is what it should, because we set up here, it's a growth model. Okay, so this says, draw from left to right a smooth curve that begins just above the x-axis, passes through the plotted point, and moves up and to the right. So that's what we're going to do. That's our last step, draw our graph. Now after this point, I'm just going to estimate. Now when we're graphing these on homework and on quizzes, there are some things I want you to make sure you're doing. First of all, this looks pretty good, right? I didn't just go like this, you know, and have it crossing the x-axis. It's a pretty neat graph. That is what we are expecting. So I'm going to say, first, you need to make sure that you plot all 5 of these points and that they're visible. So who's ever grading it can see your 5 points. You need to have arrows at both ends of your graph. And it needs to be a smooth curve. Exponential graphs are always smooth curves. And you're in Algebra 2, and you're seniors, and you're in Part 3. All these things are definitely expected. You've been drawing graphs for a lot of years now. So these are the things every graph must have. So make sure you put that in your notes. If you need to, pause the video and put it in your notes. Okay, we'll do example 4 together also. Okay, so same instructions. Tell whether each function represents exponential growth or exponential decay, then graph the function. So here is my function, and I'm noticing right away that b equals 1/2. And that is a number on the measuring cup, so I'm already thinking, this is going to be decay. So what am I going to picture in my head for decay? A graph, something like that. If you're not sure what you're going to picture in your head for decay, you're going to go back to this page and remind yourself, oh, that's what decay looks like. Okay, so identify the value of the base. I did that up here. The base is 1/2. And if the base is a number on the measuring cup, then I have decay. And make a table of values, same x values, -1, -2, -1, so on. My function this time is 1/2 to the x. So if x is -2, I'm going to have 1/2 to the -2, 1/2 to the -1, 1/2 to the 0, 1/2 to the 1, 1/2 to the 2. I think it's just a lot easier to fill those all in first and then simplify later. So 1/2 to the -2. Negative outside, what it's telling you is that both of these, this 1 and this 2, are both unhappy. So we need to switch both of them, send them to a different floor, and then make the exponent positive. So 2/1 is just 2, and 2 squared is 4. And you know, maybe that didn't occur to you right away when you looked at it. That's kind of a funky one. So we will, let's see if I can get some better light on here. I'll show you on this calculator. Let me move it up. So you want to do parenthesis. I don't know if you can see that. 1 divided by 2 parenthesis. So that's my base. Oh, there we go. That's better. And then I want to use this. Some people call it the caret, that little up arrow. That gives me my exponent. And then to the -2. And you can see I get 4. Okay. Let me show you on this calculator where you can read the display a little better because it's got a light on it. So I'm doing this one, 1/2 to the -2. So I have to wrap it up in parentheses. And I'm going to do 1 divided by 2. And then here's that up arrow on this calculator to the -2. You have to wrap it up in parentheses. I'll show you why in a minute. So I get +4. Let me show you what happens if I don't wrap it up in parentheses. I hope it does the wrong answer. Oh, it doesn't. Well, I'm going to warn you guys. I want you to always use the parentheses on these calculators. They get a little finicky sometimes, so just get in the habit of wrapping everything up. Okay, so let's do 1/2 to the -1. 1 divided by 2, parenthesis, to the -1. That's 2. 1/2 to the 0 is going to be 1. Anything to the 0 power is 1. This is just going to be 1/2. And this is the same as 1/2 times itself 2 times. So that's 1/4. I'm going to write these points as coordinate points just like I did last time. So when x is -2, y is 4. When x is -1, y is 2. When x is 0, y is 1. When x is 1, y is 1/2. 1x is 2, y is 1/4. And remember, we already said this should have this kind of shape because it's decay. So if I go over -2, 1, 2, 3, 1, 2, 3, 4. I think I put that on 5. 1, 2, 1, 2. No, that's 4. Over -1 up 2. Over 0 up 1. Over 1 up 1/2. And over 2 up 1/4. So definitely looks like it's going to have that shape that we like. A little bit steeper here this time. It's important when you draw these exponential functions as well as you can, make this look like it's approaching the x-axis, but don't have it going below it because it's not. So remember, 3 things, 5 points. Does my graph have 5 points? Yep. 1, 2, 3, 4, 5. Arrows, both ends, always. Yep. And a smooth curve. So here the directions kind of give you a clue to all that, but I can tell you on a quiz or a test, it may not. Okay, last one is for you to try. All right, so I'm going to say when you do your table of values here, go ahead and use your calculator for this, and then a nice graph. So pause the video and try this one, and then I'm just going to show you, hopefully you paused the video and have tried it, that here's mine. It is growth. 1.5 is greater than 1. These are the values I got: 0.44, 0.66, 1, 1.5, 2.25. So those are my y values, and there is my graph. 5 points, smooth curve, arrows. All right, that's it for this video.